Yo, 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 yo. Ay, ay, ay. Yo, 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 yo. So today, where's my display capture? Yeah, right, that's capturing, right? Um, so I did some studying off stream. Oh yeah, I did some studying off stream, so I'm here. Like I'm here now. There you go. Wait, let me get my where's my pen? What the fuck? Where's my pen? I need to wait. I got my pen. So I know that's study, I guess. Yeah, quadratic graphs notations. Wait. Functions are called parabolas, graphs, transform quadratic functions. Yes, the transformation. I think I'll need some time in the transformation part. Parabolas intro.
In this video, we're going to talk about what parabola. In future videos, we're going to describe it a little bit more algebraically. In this one, we just want to get a sense for what parabolas look like and introduce ourselves in this pink one, and some of them are open downwards. And you can flip the graph.
It's the maximum goal, right?
And so it meets, it would be that line right over there. You could fold the parabola over that line and it would meet itself. And that line, I didn't draw it as neat as I should, that should go directly through the vertex. So to describe that line, you'd say that line is x is equal to 3.5. Similarly, the axis of symmetry for this pink parabola, it should go through the line x equals -1. So let me do that. That's the axis of symmetry. It goes through the vertex. And if you were to fold the parabola over it, it would meet itself. The axis of symmetry.
Wait, what? 0, 1, or 2x intercepts? Yeah, that's yeah. Oh, yeah, this is easy. A graph of I don't know, I was supposed to do this. Hey, wait. The vertex is 2, 9. Yep. The y-intercept is 5, 0, 5, 8. The lesser root is minus 1, right? It's minus 1, 0. The greater root is 5, 0. 5, 0. So, yeah. Wait, what the fuck? Wait, how did both of these interchange by themselves? Like, what?
I have a function here defined as x squared minus 5x plus 6. And what I want us to think about is what other forms we can write this function in if we, say, wanted to find the zeros of this function. If we want to figure is negative 5. X equals 2. This is x equals.
This is
We take
easy.
negative 5. We take half of that, which is negative 5 halves, and we square it. So we could write this as plus negative. What's negative 5 halves squared? Why we engineered it in this way? Well, one way to think about it is this part is all.
So it's easy. What the fuck are these? Like, this is incredibly easy. So ax minus x whole square plus k, right? Ax minus x whole square plus k, where x comma k is the center, I think, is a vertex, right? So, okay, so ax minus x whole square plus k. So for that, we will do that. Yes, I can do this. So yeah, this is easy. Do a specific intercept, x into the vertex. Sifting and
Here I've
scaling.
drawn most.
Yes, this is the thing that I think I should focus on. So wait a minute. There you go. So I need to record this, right? Wait. So I have wait. Okay. Um, mm, let's translating, stretching, reflecting, or changing the function, transfer the variable. The first is the graph of f x minus c is the graph of f x to the right. Okay, f x plus c is just to the left. So the inside and the outside of the graph. Okay, so this this is important. Thus we learned that an AS, but I'm still confused by this part. Okay, so here, okay, F is to the inside, right, left, the outside, up and down. Okay, I need to make something. I need to memorize a way. So I need to find it before I to remember it. Plus up right here, it's minus is up. Minus is right side. Plus is up. What? Minus is right side. Okay. So inside the graph is right, left. The inside is right, left. Outside is up, down. Inside minus is to the right. Outside plus is to the upwards direction. Yes. So wait, why do I have a tough time remembering this? What? Oh, okay. So if I, so we do f x plus 3, then it'll shift to the left by 3 units, right? By 3 units, yeah. The outside is up and down. Okay, this is easy. What? Okay, now this is fucked. The graph of y is equal to minus factor c. So reflection and stretching. So only okay, I need to realize this. So this I don't know how to make the graph. Never mind. I do it. I think. But it is another. Jeez. Hi. What was I saying from 2 to 6? Yeah, yeah, yeah. So my outside we got reflected across the x-axis, right? So this is inside is reflected across the y-axis. So I just need to remember this. So we have fx function x plus c. So there's a function fx plus c to the outside, then it's go up. If fx minus c, then we go right. We got fx plus c in the inside, it'll go left. If we got fx minus c in the inside it'll go right. Yeah, it'll go right. If we got fx minus c in the c is in the outside, then the graph will shift towards downwards by c units. Okay, there you go. And we have reflection and then reflection to for the reflection across x-axis. What do we need to have to do? So we need to transfer the graph fx as minus f bracket x. The minus is the negative sign is outside the bracket fx, but uh, alongside f, not alongside x. So wait, I just remembered this. Okay, So minus should be alongside x. If the minus is alongside x, then it's not in x. If the minus is not along x, then it's and of course x-axis. If the thing is across, not along x, then it's downwards straight. So it should show axis. So yeah. The graph of is of 4 units. Okay, so this is question, right? So it's plus 3. So it's for 3 units upwards, up, and then we got 4 units left side. Okay, the graph has volume open up outward and as a vertex located at 2, comma 1. The graph of y is fx as a vertex located at same as 2, comma 1. The opens f. Okay, so opens upwards, right? So it opens upwards before. So with the minus of it's alongside y-axis, right? It's still upwards. There's no is. Wait, what? Wait, what? The graph f comma minus x has a vertex located. The vertex changes. What? I didn't know that. Wait, I need to try this. So you got decimals. Minus x, then what? Minus 2 comma 1, as I said. What the? What? Wait, I don't know the answer to this question. Wait, oh my god. So you got fx is equals to x bracket x minus, what's the h here? X comma 2 whole square plus 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 square plus k. Yeah, x minus h whole square plus k. Well, let's do the graph gx, right? So it's gx is equals to y is equals to gx is equals to f minus x. F minus x. Oh, so it's reflected, right? It's shown upwards. Wait, f to the inside of minus x, so it's reflected by y-axis, right? It's x-axis, so it's downwards. Yeah, it's downwards. Yes, it's downwards. So just if we go to the left, we'll have. Okay, okay, it's the quadrants right there. Oh my God. Okay, nice. So it's in the first quadrant, right? So we'll move to if we reflected it reflected it through the y-axis, it will be in the second quadrant. In the second quadrant, we have minus x and then plus y. Okay, there you go. Okay, I understood this concept. Let's go. Let's go. I think I have it on my mind now. There you go. Boom, let's go. So we have okay, that's actually what I understood. I now understand how to do these questions. These questions, yeah. So what are the coordinates of the vertex is 3, comma 11? Wait, x minus h whole square plus k. Oh my god. So the following could be f. The vertex is 1. Wait, it's x minus 3. And then we have x minus 1, right? We have x minus 3 and x minus 1. So x minus 3, and then we have x plus 1. Yes. That is the following. The x coordinate is the y intercept, right? Wait, bro, what? We have the key, right? So x comma k. It's not the x-coordinate of the vertex, it's the maximum y value of the graph. It's the x-intercepts. It's the x-coordinate of the vertex. What? Okay, okay, I didn't understand the question. My bad, my bad. Okay. There you go. Dang, dang.
We're told the graph of
Yeah, of course, it's a point. Okay, this is easy.
we're asked.
Uh, Switch to. Okay, that's wrong. Right, D is the right answer. D is the right answer.
X equals 3 and x equals
Let's go! Okay, the graph of y is equals to, so you want the coordinates of the y-intercept of the graph. It's minus 4, comma 0. That's B. This is the following items of the graph is free as a constant of the equation. Blah 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 blah. Which is the item of the graph is free as a constant of the equations. So we have x-intercepts. No, we have the y-intercept. No. Okay, we have the minimum y value, maximum y value. The question is, I don't know the answer to this question at all. Right there. So I don't know the answer to the question at all. First of all, 2 comma 6. No, this is wrong. This is wrong. The minimum y value. Do we have the minimum y value? Yes, the minimum y value is the right answer. Okay, the graph. No, no. What are the coordinates of the zeros of f? What coordinates of the zeros of f? What does this mean? Coordinates zeros of f. There's only 0 comma minus 9 only, right? No, there's 0 comma. There's 3 comma zeros as well. 3 comma 0. And then minus 3 comma. There's no 3 comma 0. What do you mean? Actually, plain what is the coordinates of the zeros of f? Wait a minute, we have zeros minus 3 comma 0 as well, right? What are the coordinates of the zeros of f? What does it mean? What does the zeros of f mean? It's in O comma 9, minus 9. No, I think minus 3 comma 0 takes it. Okay, we'll know it. We'll know. Wait a second. There you go, okay. Let's know on the graph. I may have seen this, so let's reflect that. Uh, this point is the y-intercept, right? This is the 0x coordinate is the only point on the graph with a y coordinate, 0. So there you go. I mastered. Okay, never mind, I have one question left too. Okay, the graph of y is equal to minus this, which of the following characters of the graph is displayed as a constant or coefficient. Uh, we have the y-intercept here. Y-intercept is minus 1. Let's go to more. What are exponential graphs? An exponential function. Okay, the graphs of x to x and x is x. How do you know this? How am I supposed to know? Wait. Okay, so it's plus one, right? So it does not touch one. It does not touch one. It does not touch one, right? Okay, so it does not touch one. And how do I know it's 2x? Okay, there's a graph exponential functions. Okay, this is a new thing for me. I know the features of exponential functions. How do I graph exponential functions?
This is from the graph basic exponential functions on Khan Academy. And they ask us graph the following exponential function. And they give us the function h of x is equal to 27 times 1/3 to the x. So our initial value is 27 and 1/3 is our common ratio. It's written in kind of standard exponential form. And they give us this little graphing tool where we can define these 2 points, and we can also define a horizontal asymptote to construct our function. And these 3 things are enough to define to graph an exponential if we know that it is an exponential function. So let's think about it a little bit. So the easiest thing that I could think of is, well, let's think about its initial value. Its initial value is going to be when x equals 0. X equals 0 is 1/3 to the 0 power, which is just 1. And so you're just left with 27 times 1, or just 27. That's why we call this number here when you're written it in this form. You call this the initial value. So when x is equal to 0, h of x is equal to 27. And we're graphing y equals h of x. So now let's graph another point. So let's think about it a little bit. When x is equal to 1, what is h of x? It's going to be 1/3 to the first power, which is just 1/3. And so 1/3 times 27 is going to be 9. So when x is 1, h of 1 is 9. And we can verify, well, and now let's think about the asymptote. So what's going to happen here when x becomes really big? Well, if I take 1/3 to like a really large exponent, to say to the 10th power, or to the 100th power, or to the 1000th power, this thing right over here is going to start approaching 0 as x becomes much larger. And so something that is approaching 0 times 27, well, that's going to approach 0 as well. So we're going to have a horizontal asymptote at 0. And you can verify.
What? I need my calculator to verify this. So, if we 1/3, right? If we have it as 99, yes, yes.
Verify that this works for more than just the 2 points we thought about. When x is equal to 2, this is telling us that the graph y equals h of x goes through the point 2, 3. So h of 2 should be equal to 3. And you can verify that that is indeed the case. If x is 2, 1/3 squared is 9. Oh, sorry, 1/3 squared is 1/9 times 27 is 3. And we see that right over here. When x is 2, h of 2 1/8. As you get larger and larger, think about this. So when x is equal exponential function, so same logic, x 3, 1/3. So h of 2 should be about that. Let's do another one of these. So graph the following exponential
We graph some following. So we have minus 30 first. Okay, so we need to take it to the below quadrant, right?
function.
So
So
quadrant
let me scroll down. The initial value is negative 30. And so
then we have 2x. So if when x equals to 0, we have x equals to 1, we have
let's think
minus
about when x is
60.
equal to 1, when x asymptote, where that should sit. So let's think about what happens when x becomes really.
And so we just need to think about when x becomes reduced in the dollars. So we got 9999. So we have uh what happens? So we get a very big number, right? Times minus 30. So we have 9999. So it becomes very small.
And so let's think about when x is equal to 1, the value of the graph is negative 60. Now let's think about this asymptote, where that should sit. So let's think about what happens when x becomes really negative. So when x is really negative, so 2 to the negative 1 power is 1/2, 2 to the negative 2 is 1/4, 2 to the negative 3 is 1/8. As you get larger and larger negative, or higher magnitude negative values, or in other words, as x becomes more and more negative, 2 to that power is going to approach 0. And so negative 30 times something approaching 0 is going to approach 0. So this asymptote's in the right place. Our horizontal asymptote, as x approaches negative infinity, as we move further and further to the left, the value of the function is going to.
And there's something new, actually. Also, last is here. Gotcha. So we have translate.
All right, we are asked to choose the graph of the function, and the function
Okay, so the answer is this one.
is f of x is equal to 2 times 3 to the x is 2. So just through elimination, through that alone, we can feel pretty good that this third graph is probably the 2 times 3 to the 1, or 2 times 3, which is equal to x increases by. And you could also go the other way. If you're going down by 1, you should be dividing by 3. So 2 divided by 3, this does look pretty close to 2/3. So we should feel very good about our third choice.
Ah, my knees. I want. So this. What is left? What? Yeah. No, 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 no. That, that. No, 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 no. I just learned something new, right? So it does, right? So I'll literally just look at it and be like, the one stuff is D with the girl that's it from plus D, right? So it's obviously here, there's A plus D. There. There you go, we learned a new thing. Da na 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 na. Do 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 do. Meow. Meow. Uh, thank you for the like. Actually, very encouraging. I'll do more of these strips tomorrow as well. Because the exponential function, the initial value of the function is 64. Because the base of the exponent 0.25 is less than 1, the slope of the graph is negative. Negative as the value of x increases by 1. Wait, what? As the value of increases by 1, the value of x increases by 1, the value of y is uh, divided by 0.5, right? Check. Wait, it's multiplied by 0.5. Fuck, if it decreases like that, it's not divided, it's multiplied, yeah. The following is a graph of 4,5x. So, we have the y-intercept as 4. Okay, now the this thing is less, right? Less than 1. So it needs to have negative slope. Which is the following the graph of fx plus 2, right? So fx plus 2. So if we do this, right, I'm supposed to the graph should shift by 2 points upwards. So that makes sense. So that means the graph's y-intercept should shift by 2. It needs to be in 3, right? The y-intercept needs to be 3. So first of all, how many of those do we have, right? We only have one with the zero answer. Positive real numbers, the constant 0 to the delta. What is it is deep, blah 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 blah. Let's go.
We're told that the graph.
What is the following would be F. So it's 8, right? A is the wrong answer, straight up. So, and D is also the wrong answer because it has a positive slope. Now it's between B and C. So, between B and C. So now we need to just basically take one of the points where you can determine this. Suppose I take this point, right? It's 5 comma 2. So now input this in our calculator. So we got if x is equal to 5, does fx is equal to 2. That's the x equals to 5. No. Now, if x is equals to 5, wait, what? 3 by 4. 3 by 4. 2, yeah, so I think C is the right answer. Wait a minute. Am I wrong? No, right? I'm not wrong. Definitely I'm not wrong. So let's take this for example. We got 7 comma 1. 7 comma 1. So we take x is equals to 7, right? 7. 1.0, right? So we have 1 by 8. So yeah, C is the right
F of
answer.
exponential to another point would actually look something.
There you go.
We're told the function.
The function f is defined by the equation over which the whole is the graph of y is equal to. Okay, what happens when we this is not fuck, I forgot. It's reflection to y-axis, yes. No, it's reflection to x-axis, right? It's definitely reflection to x-axis. Yes, it's reflection to x-axis, right? So that's right. One. Why does have to one? I don't know the fucking answer to this. It's not the y. It's not the y-intercept. I actually do not know the answer to this question. So first of all, 1 by 3, right? So we're 1 by 3, so it's definitely decreasing. So both of these are wrong, A and B are wrong. So it's either between C and D. Whether it upwards or is it not laughing? Okay, that's the X, Y, Z stuff. That's a variable right there. I have no idea.
F is defined by the equation above, right over here. Which of the following is the graph of y is equal to negative f of x in the xy plane? Pause this video and see if you can work through that. All right, now let's work through this together. So first of all, let's think about what y is equal to negative f of x is equal to. Well, that's going to be the negative of the right-hand side over here. So this is going to be, we could write it as negative 1/3 to the x, and then if we distribute the negative, it'll then be plus 1, or we could even write it like this. This is the same thing as 1 minus 1/3 to the x. Now, there's two ways that you could approach it. You could think about the behavior of this expression as x becomes very large or x becomes very small. Another possibility is we try a table with some easy values. So let me start actually with the table method right over here. So let me just try some easy x's to calculate and figure out what the corresponding y is when y is equal to negative f of x. So one easy one would be, well, we could try 0, but we could see every one of these graphs have the point 0, 0. So that won't really help us differentiate between the graphs that well. But let's try the point 1 and let's try the point -1. And those are useful because they're pretty easy to calculate. So let's see. When x is equal to 1, 1/3 to the first power is just 1/3. 1 minus 1/3 is 2/3. Now when x is equal to -1, what's 1/3 to the -1 power? Well, that is equal to 3. And so 1 minus 3 is equal to negative 2. Now let's see, just by inspection, if we can tell which of these graphs contain these two coordinates. So 1 comma 2/3. So 1 comma 2/3. That looks about right. So this one is looking pretty good. B, 1 comma 2/3. This is definitely larger than 2/3, so I would rule that one out. 1 comma 2/3. This looks like negative 2/3, so I'd rule C out. 1 comma 2/3. Definitely nothing right over here, so I'd rule D out. So A is already looking pretty good. But let's just confirm -1, -2. -1 looks like the point -2 is there as well. So I'm feeling very good about A. And you could even check -1, -2.
We're so used to use the table method. Yo, what? Everything that I've learned through. What the fuck? I didn't expect this at all.
The graph doesn't go through there. -1, -2 doesn't go through there. -1, -2 does not go through there. So we really like choice A. Another way that you could have thought about it is when x is very negative.
Wait, why is it 1 minus 1? That's 0, right? 1 plus t. Yeah, why is that 0? Yo, I'm dumb. Yo, I'm dumb.
when x is very negative, 1/3 to a very negative power is the same thing as 3 to a very large power. And so you'll have 1 minus 3 to a very large power. Well, 3 to a very large power is going to be a large value. So 1 minus that's going to be a very negative value. So when x is very negative, your graph should get very negative. And this one checks that box. As x gets more and more negative, this graph is just really getting more and more negative. And then as x gets larger and larger and larger, more and more positive, well, 1/3 to larger and larger positive exponents is just going to get closer and closer and closer to 0. So you're going to approach 1 as x gets larger and larger. And it looks like that is what is happening with this graph right over here. As x gets larger and larger and larger.
So I'll just need to do way more exercises. I'll start the constant of right? So we do not have one separate out. One subtract what's the y-intercept for this one? We had p8 as well as the value. So yeah, see it's a value. A value of y. Okay, so we have the actions have no, we have y set no. Yeah, the slope. Yeah. Wait, as 1 by 1 slope. I don't know. Just to find out the value y approaches as x increases. Wait, this is these are as up. Wait, yeah, I'm bad. You what? I'm bad. I am so bad. That's the y-intercept right there. I saw initial value in my notes and I was like, that's not initial value is not the y-intercept. While it is numb. Therefore, y is equals to this, which is the following. Um, Graph of y is equals to 509.6 axis. So is the following. As x increases, that's wrong. As x increases, y decreases at a decreasing rate, right? So is the slope decreasing? So it's correct answer. D is the answer. So the graph of this, the y-intercept should be -1. There you go. Y-intercept is in the equation. We do not have the y-intercept. Hmm. I'm doing it once more. Mm. Mendel's theorem. What's the polynomial Mendel's theorem? What? I should know. I'm. I'm. I definitely know this. Mm-hmm. Oh yeah, yeah. He can learn anything. Let's do this. I'll have pieces of that from polynomial functions.
Let's say that we have a polynomial p of x, and we can factor
You, that's it. Two settings back to solve the equation. Mm, okay, that's easy. Six, okay, I need to learn this and verify it as well. So I learned this and verified as well. So we are y equal to x squared plus a. No, we are y equal to x equal to x squared plus a equal to. So if a is greater than 0, it produces positive infinity as x increases. So less than 0, it approaches negative infinity. So we can cancel out these. Now for this right, we got x is equals to s2 for x cubed plus 6x squared plus squared plus plus 2x minus 4. So minus 4 is the intercept. So we got a is greater than 1, right? A greater than 1, so negative positive infinity, minus produces negative infinity. If n is even, what is n? What? Yeah, the I is for, we just need to see the I is for term, yeah. If n is negative, or different directions. Yo, this is so easy. What? If a is less than 0, then positive. Infinity a is less than 0, then negative infinity. If a is even, then same, different. And is off, then is as wait, a is even the same direction. But even in different direction. Man, okay, this is easy. One, two, three, four. Four unique zeros.
So let's introduce ourselves to x minus 1. So a division. And so what do we get?
I'm supposing I'm not doing it. Of course, I know all everything. So simple rational functions. Okay, we have a problem here. I'm way too lazy for me to be studying these things. Hello, I'm watching you. You should. It has been watching. Okay. Yo, I'm scared. Fuck. What are these? What are these, brother? What the fuck? Why did I have to learn new things? I thought SCT was just grade 9 level fucking maths. What do you mean? What do you mean? What are these? Why do I need to learn how to graph these? For fuck's sake. I hate this. I hate this. I hate this. I hate this. I don't like studying at all. So before moving on, let me just root this transformation. So we have if C is added in the outside, plus then it goes up, minus then it goes down. If C is added in the inside then it goes left. Wait. No. So wait. Okay. So Capito così, no, questa è no, no. Ne chiede, no? Ne chiede, no? No, 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 no. Ay, ay, ay. I'm back, I'm back. It's a desktop audio. What? I meant to mute my mic. How do I mute my mic? What? How to mute mic? Right there. How do I do that? How to mute mic and OBS. This one.
Hello everyone, how are you? Toggle or mute your
Yeah.
microphone in OBS Studio. So this should hopefully be a pretty straightforward process, guys. And without further ado, let's go ahead and jump right into it. So all you have to do is
Okay, we don't have to do anything. Right there. I know all the remainder theorem functions. So not much. If the graph of y is equal to f equals graph index rate clean. C is a positive constant. Yes, to the inside negative is the weight rate. Yes. Up down if you have one. Access rate. Fuck, if it's with x, then it's y axis. If it's without x, then it's x axis. Yes. Goes to x axis. Okay. Okay. I got you. I learned this stuff. Let's go. Let's go. I'm watching you. Hello. Hello. Wait. Now, brother, I'm so fucking bored. I don't want to fucking study this. Okay, think rational functions are more like x and less like. Okay, so we have one divided by something. Okay, so wait, I cannot separate this, right? So okay, undefined, and particular similar as and mass division by O is impossible. Any attempt to divide by zero is an equation that's considered undefined. Therefore, a rational function is undefined. Its input results in a function that asks us to divide by O. For example, f(x) is equals to 1 by x is 2. f(2) is defined because when f is equal to 2, then a denominator is 2 minus 2 is equal to 0. If the in the graph of the satisfy the function as defined, blah blah blah. What is the value of f(x) as x approaches to? It goes to infinity. So we all. What the fuck? This is boring. This is so fucking boring.
Right over here, I have the graph of f of x. And what I want to think about in this video is whether we could have sketched this graph just by looking at at the definition of our function, which is defined as a rational expression. We have 2x plus 10 over 5x minus 15. So there's a couple of ways to do this. First, you might just want to pick out any numbers that are really easy to calculate. So for example, what happens when x is equal to 0? So we could say f of 0 is going to be equal to, well, all the x terms are going to be 0, so you're going to be left with 10 over negative 15, which is negative 10 fifteenths, which is negative 2 thirds. So you could plot that when x equals 0, f of x, or y equals f of x, is negative 2 thirds. And we see that point. Let me do that in a darker color. You see that point right over there. So we could have plotted that point. We could have also said, when does this function equal 0? Well, the function is equal to 0 when the only way to get the function equal to 0 is if you get this numerator equal to 0. So you could try to solve 2x plus 10 is equal to 0. Well, that's going to happen when 2x is equal to negative 10. I just subtracted 10 from both sides. And if I divide both sides by 2, that's going to happen when x is equal to negative 5. And you see this right over here. When x is equal to negative 5, the function intersects the x-axis. So that's just 2 points, but that still doesn't give us enough to really form this interesting shape over here. And you can think about what other functions have this type of shape. So now what I want to think about is the behavior of the function at different points. So first I want to think about when this function is undefined and what type of behavior we might expect for that function when it's undefined. So this function is going to be undefined. The only way I can think of to make this undefined is if I make the denominator equal to 0. We don't know what it means to divide by 0. That is undefined. So the function is going to be undefined when 5x, this in blue, when 5x minus 15 is equal to 0, or adding 15 to both sides when 5x is equal to 15, or dividing both sides by 5 when x is equal to 3, f is undefined. Now there's a couple of ways for a function to be undefined at a point. You could have something like this. So let me draw some axes right over here. So let's say that this is 3. You could have your function, it could look like this. It could be defined, it might kind of approach something, but just not be defined right at 3 and then just keep on going like that. Or the other possibility is it might have a vertical asymptote there. And if it has a vertical asymptote, it's going to look something like this. It might be approaching, it might just pop up to infinity, and then it might pop down from infinity on this side, or it might go from negative infinity right over here. That's what a vertical asymptote would look like. That as we approach from the left, the graph is approaching a vertical, but it never quite gets to x equals 3. I guess one way we could say it, or the function is not defined at x equals 3. And as you approach from the right, the same thing. The function just, in this case, drops down. It almost becomes vertical. It's approaching negative infinity as x approaches 3 from the positive direction. So how would we know? Obviously, when you look at here, when we know the graph ahead of time, and if you say, okay, this is x equals 10. So let's see how many this is. 1, 2, 3, 4, 5. So each of these are 2. So x equals 3 is right over here. When you look at the graph, if you had the graph in front of you, you would see, oh, look, this is indeed a vertical asymptote. Just looking at the graph, you see that you have a vertical asymptote at x equals 3. And let me write that down. Vertical asymptote. Vertical asymptote at x equals 3. At x equals 3. But how would you have known that? How would you have known that if you didn't have the graph here? If you just had this? We know it's not defined at 3, but how do we know it's not a point discontinuity and not instead of a vertical asymptote? Well, there's a couple of ways to do it. One way is you could try values near 3 and see what happens. So for example, you could get your calculator out and you could try, let's say, 3.01. So if you say 2 times 3.01 plus 10, actually, well, that's the numerator. And then I'm going to divide the numerator, by 5 times 3.01 minus 15. It gets us a fairly large number. It's kind of exploding on us. And if we got even closer, so if we did 2 times 3.001 plus 10 divided by 5 times 3.001. So now I'm trying x is equal to 3.001 minus 15. We see we get even a larger number. So as x gets closer and closer to 3, f of x seems to be exploding. It seems to be approaching positive infinity. So that's one way to say, okay, this looks like, at least from this side, we are approaching positive infinity. So we would have been able to draw something like that. And then you could have tried values below. So you could have said, actually, let me just put the last entry here. And let me just change the 3.001s to 2.
What the fuck? This is so fucking boring. Holy shit. This is boring. I'll do it off stream. My bad. Bro, what the fuck? This is so boring. No, no.
999, 2.999, and
Like, I didn't understand any of the shit he just said. He just said, let's see, do x minus x 10. So f(x) equals to 1 by, so we got output to x 10 plus 10 to x plus 10. And then below we have 5x minus 15. So we see from the graph that it's approaching 3, right? How do we know it's approaching 3? How do we know that the word? Okay, so first of all, what we need to do is we need to find the axis where that's you know and infinity as that by denominator, right? The plus is this. It's not something like this and that. So we got when x was 2, 10, x was 10. Then x goes to 5. And x goes to 5. No, it's when x goes to minus 5, x is 0, right? So we know this point. We can find this point as well. So, yeah. I think we just try. Right. Like I just said, we just try. How do I know if it's like this and like this, not like this? Maybe there's a point where with both of these graphs it does do not approach at all. It seems to be it seems to be greater than 1, somewhere like over 5. How do I know that point as well? 0.5. So when y is equal to 0, what happens? When y is equal to 0, x is equal to fuck. Okay, towards this.
10, I just subtracted 10 from both sides. And if I divide both sides by 2, that's going to happen when x is equal to this. Be undefined. The only way I can think of to make this undefined is if I make the denominator equal to 0. We don't know what it means to divide by 0. Is undefined over here. Just not be defined right at 3 and then just keep on going like that. Or the other possibility is it might have a vertical asymptote there. And if it has a vertical asymptote, it's going to look something like this. It might be approaching, it might just pop up to infinity, and then it might pop down from infinity on this side, or it might go from negative infinity right over here. That's what a vertical asymptote would look like. That as we approach from the left, the graph is approaching a vertical, but it never quite gets to x equals 3. I guess one way we could say it, or the function is not defined at x equals 3. And as you approach from the right, the same thing. The function just, in this case, drops down. It almost becomes vertical. It's approaching negative infinity as x approaches 3 from the positive direction. So how would we know? Obviously, when you look at here, when we know the graph ahead of time, if you say, okay, this is x equals 10. So let's see how many this is. 1, 2, 3, 4, 5. So each of these are 2. So x equals 3 is right over here. When you look at the graph, if you had the graph in front of you, you would see, oh, look, this is indeed a vertical asymptote. Just looking at the graph, you see that you have a vertical asymptote at x equals 3. And let me write that down. Vertical asymptote. Vertical asymptote at x equals 3. At x equals 3. But how would you have known that? How would you have known that if you didn't have the graph here? If you just had this? We know it's not defined at 3, but how do we know it's not a point discontinuity and not instead of a vertical asymptote? Well, there's a couple of ways to do it. One way is you could try values near 3 and see what happens. So, for example, you could get your calculator out and you could try, let's say,
So how do you know it's just a self-vertical asymptote and not a point of?
vertical asymptote at x equals 3. At x equals 3. But how would you have known that? How would you have known that if you didn't have the graph here? If you just had this? We know it's not defined at 3, but how do we know it's not a point discontinuity and not instead of a vertical asymptote? Well, there's a couple of ways to do it. One way is
It's not a point of discontinuity, right? It's not a point of discontinuity. So we try to calculate, right? So we try to invert different values that's closer to. What is it? It's 2, 3. Okay. I was like, I get it. I think I get it. Okay. I think I get it. Yeah. I think I get it. Yeah. Here's the value of x is the value of x is 6. Okay, what's that? 3 fours are 12, right? Minus 4 is a good answer. So the function is rather x process the vertical asymptote. X approaches. Just right. That is 3 times bracket, right? Plus 12. 12. And this is was answered from the negative direction. So from the negative direction, so we got minus 4.9, minus 5, minus 4.01, right? 4.01. And the process is 4.01. So as we increase this, y process to positive infinity. Positive direction. Here was the positive direction. So it's 4 minus 4, right? Sorry, minus 3.99. Negative infinity. Okay. See. 4 less times 0. So we have 1, 2, and 3. We got 1, 2, 3, 4. 1, 2, 3, 4, 5. We got 1, 2, 3, 4, 5, 6, 7 at math questions in my Discord server. Questions in my Discord server. Questions in my Discord server. In the xy plane, the graph of function, blah blah blah, which is one going to find x. This is easy, I'm not doing it. Let's see, value of x minus 1 is minus 7. For the draw, let's do. So 0 put to infinity is less than 0. Stay with it.
The polynomial p of x is.
What the fuck is this? Are you
Whereas
taught
which of the
me
following could be the equation?
so many harder questions? Bro, what the fuck is this? Yeah, this is actually guys, huh? It's x minus 3 and x plus 4. Right, x minus 3 and x plus 4. So it's between a and b. So it's 1, 2, and 3. So it's definitely 8 because it has 3 roots.
Square of that, so you're going to get a positive square liking choice.
Wait, what? We only have 1, 2, 3. 3 though. I don't understand.
And then for x equals 3 to make the entire expression equal to 0, you need to have an x minus 3. And we can see we have an x minus 3 and an x minus 3. So now we have to decide what makes more sense to have a negative x out here or a negative x squared. Well, let's think about what would happen in either case as x increases. As x increases, as x becomes larger and larger positive values, you take the negative of that, and it makes sense in this A choice that the value would get more and more negative. That's also the case in choice B. As x increases, you square it, you'll get even a more positive value, and then you take the negative of that, it should go down. So both choice A and B is consistent with this behavior of as x becomes more positive, y is becoming more and more negative. Now let's look on the other hand. What about when x becomes more and more negative? Well, when x becomes more and more negative, in choice A, when you take the negative of a negative, you would expect this part to become more and more positive. So you would expect for choice A that actually the y values would increase as x becomes more and more negative, which clearly isn't happening. So we could rule that one out as well. But let's just verify that B works. So when x becomes more and more negative, you take the square of that, so you're going to get a positive value. But then you take the negative of that, so it's going to become, so y will keep decreasing and becoming more and more negative, which is exactly what we see in this graph. So we're liking choice B. Whereas which of the
Oh, there's something new. It's then made so much of me approaching. Of course, I was telling anything that that's true. So it's approaching negative, right? Okay, more than positive. Ah, yes, bro, that makes so much more sense. Wait, how am I supposed to know? Like, exactly, how am I supposed to know? Zero. So you give us so we you teach us so much part of stuffs and the previous lessons, and then and the exercises give us like a minimal difficulty questions. So what is this? Minus 2 plus 3 minus 11 plus 1. You got minus 9. Minus 9. There you go. Wait, what? Ah, I'm dumb. I'm dumb. Bro, I'm dumb. I'm so dumb. Nope, I'm doing it again. I am doing it again. Factor 6 is a factor. Function at what? 0. Pull. Yeah, quiz 3. Put in the work from 5. Oh, it's up, yeah. Yo, let's go. So we take the final question, right? Unit test, yo. Okay, 13 to 26 minutes. Actually, let's just time this. How much time I take? Okay, stop. Let's go. What is the value of y when x equals to 1? Now is the following related of expression above. What is this? Wait. Never mind. I'm taking a break. Wait. Mm, 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 mm. Okay. Fuck, I'm sleepy right now. I'm so sleepy. Yo, you're gonna see me do my unit test right now. Wait, wait, wait. I need to. Da-na-na-na. This unit test. Da-na-na-na-na. Wait, wait, wait. Okay, see me is this unit test. Okay, wait. Where's my fucking time? Okay, I have everything. Is it the following as equivalent to the expression above? Ah, A by BC. Uh, the characteristic, right? So we do not have the minimum y value. Accent is over the line of symmetry, no. Wait, I forgot. Fuck. Fuck, I forgot. Do we have the x-intercepts here? So, no, we don't. Minimum y value. What's the minimum y value? Do we have the y-intercept here? 4. No. We have the x-intercept of the line of symmetry. X minus 1, yeah. So z is the following. K is equals to 5z by 4. X is equals to s, blah, blah, blah. So the following is equal to the value of s minus t. What bullshit is this? 4 minus 5 minus 1. This is 1 is over there. The graph is an equation, and graph is the following statement. As x increases by 1, it's increase, right? It's increases. This is doubles. What the fuck is doubles? Wait, when x increases by 1, x increases by 1, it doubles, right? So it's 3, 2, 4, 8, 8, 16, yeah. Yeah, this third answer. 100. Wait, disappear, taskbar. What the fuck are you doing here? Uh, this thing solution was the sum of y1 and y2. This is so fucking bullshit. Wait, I need to solve this. Fuck, I need to solve this. Wait, 3x plus 50. 3x plus 50 equals 10 plus 16, x minus x squared. So we have x squared minus 3, 13, right? 16, 15, 14, 13, 13x plus 40. Ay, ay, ay. 5, 3, 1 minus 13, 48, comma 5. We have 8, comma 5. So we got 3 times 8 plus 50, 74 plus 3 times 5 plus 50. 65 plus 74, we got 139. Na 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 na. That's a wait. Is this a real question or what the fuck are they making you do here? Wait, is this real acidic questions? What? How many? Okay, wait. I need to use my brain on this one. How many seconds does the air ever reach the surface? Whereas d is equals to 0, right? When d equals 0, in addition, the equation shows that. Okay, first of all, we need to solve. What the fuck? These, these are the- Wait, what the fuck? We need to find 3.2. Wait, this is actually hard. What the fuck? Nice, nice question. And air pump increases the oxygen levels in aqua. It reduces the buildup of waste materials. Says tough and this one. Yeah, we need to solve this one. What the fuck? Okay, solve this question. What? T equals 3.2, 3.2 T plus T equals 3.2. It's supposed to be easy, right? 2 tables, 3. We don't have the answer is 3.2, which there's no way. After how many seconds does the ever reach the surface, right? Surface, if depth is equals to 0, right? That's definitely one of the questions. So when d is equals to 0, we have t is equals to minus 1 and t is equals to 1.5. So I think 1.5 is the correct answer because there's no way in. Okay, why was I doubting myself there? So 1.5 to the power 2 plus 1. 13.2, 3.25. 3.25. Boom, ace. Yo, I don't know. Goku. Na, 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 na. Okay, I need him to do this question right here. Let's do this question. I had to think for a second. Okay, so there you go. Today, what I did was complete the lesson 4, right? I completed the lesson 4. So I might do some more off stream. So I might do some more off stream, but I don't know if I'm going to continue studying. Maybe I will. Okay, yes, I'll complete this. Like, this is bullshit.
Jamie.
This is bullshit. This is some dog shit question. So the volume is definitely like as 4.25, right? 0.25 times 2 times 3. This is like the dumbest question ever. It's 0.25 times 2 times 3. This is dumb. You just need to memorize these questions, right? So we don't need to remember founders of actually reference. Okay. Rectangular cone. Yes. Like this is just bullshit. Like geometry is easy as fuck. Because I've been no math is just fucking backfires. Okay, yeah, so I'll do unit 5 off stream. I don't think I'll do this on stream. I'll do this off stream, yeah. So I got unit 5 down today, right? I'll do the unit 5 today and then yes, and then I'll complete the foundations. There you go. Yeah, progressing so slowly, shit. And then I think I'll start doing what do you call that? Start doing the English test as well, right? Wait, my courses, yeah, dsat, right? Yeah, there's nothing here. Like the problem with this is just literally nothing here. But I think I need to like study a lot. Doesn't that make sense? Yeah, so we have this, and this, right? Yeah, it's just 5 units. And when it comes to the DSAT, we have 111, 30 units. Okay, it's half the work. Okay, yeah, unit 5. So I'll complete unit 5 today, definitely. And then maybe unit 6. As I don't know the contents of this unit 6. Wait, why does it take me straight? Okay, I think I'm good.